All right, I hope you guys are doing well. In this video, I'm going to go over the flywheel project. Flywheel project. And so some of the questions that I've been hearing from you guys are, how do I cost the tooling? So in this one, you're specifically given the rates for you know, the punch and the drill fixture. So that would be what you probably have to consider for this project, are those two fixtures and dies. This is a punch die and a drill fixture. And then some of the other questions are, how do I cost the CNC milling costs? And then third one is, how do I account for the scrap costs? And then for all of these, I'd really like to know your assumptions. So assumptions are really quite important because assumptions at the end of the day are how a company determines if they can make money. So let's say they want to bid on a contract for making a bunch of parts. I don't know. It doesn't matter what the parts are. It could be anywhere from defense to tractors or glass jars. It doesn't really matter, but their assumptions include like dollars, per product, like revenue. I mean, so revenue is everything that you take in. So it's just if you're selling something for $25, you make $25 on it, or you take in $25. But that doesn't mean that you get to put that $25 in the bank. You had to pay for that making that product. So there's product cost. So seasoned manufacturers will have a really good idea how to cost the product, and how long it, cycle times. Until you build it, you don't know your cycle times, but you can make an assumption based on time studies. So some people are hired to do time studies, see how long it takes to make a product. So these are all this data in the end is an assumption because it's not the actual measured data of making that product. It's just an assumption. So that's why these are key in this in this cost analysis. So I think going back a little bit before I even touch on how to, cost out your punch die or CNC costs, I think we need to understand the break-even point. Okay, so break-even point. So the break-even point occurs when your revenue, so the money that you're taking in, minus their cost to make that product, minus the startup cost equals 0. So let me write that out. So your revenue per part minus the cost per part. So that is, this in total is profit. You hope. Sometimes the cost of the part is more than the revenue. And then we like to break out the startup costs. So because it's not, the first part is always the most expensive. Let's say you buy $1 million machine to make the prototype part. So how much did that part cost? It cost $1 million. That's $1 million part. It doesn't matter what it is. It could be a washer. It could be it could be something that you would not pay $1 million for. Would you pay $1 million for a washer? No. But you're anticipating that that machine is going to make you money in the long run. So to get it per part, so this all has to equal 0. All right, and then but it's really not your revenue per part minus your cost per part. It's how many parts. So we'll denote that as X, and maybe I'll just make that in a different color too. X. So we can rearrange this to look like this. X and I'm just going to call it rev per part, revenue per part. Not revolutions, but revenue. Minus the cost. And I'm also going to put in units at this point. Like part is a unit, but I haven't really put the dollar signs in. There's a dollar sign there, and there's a dollar sign there, and a dollar sign there. Okay, so then I can isolate X. And so X is really the number of parts. So X number of parts equals startup cost divided by revenue minus your cost per part. And so this is your dollar sign as well. And a neat thing happens here is that you can switch to red here, so you can cancel the dollar signs. And then the part, because it's on the denominator of the denominator, so the unit of the denominator always goes up into the numerator. That goes up there. So we can neatly write this formula like this. X equals your startup cost, your revenue minus cost, and part or parts. So this relationship here will get you your break-even point of how many parts you need to sell until you just hit 0. So you've made your money back. And if you do that in a short period of time, you don't have to think about the costs of your loans that you took out to buy the machine and the time value of money and Because if you have $5 today, in 5 years, that $5 is not worth $5. If you just kept it in your pocket, it's now worth, less than what it is. So this is kind of a dumbed down version that I'm not going to go into that. Because we're going to assume that we're going to make our money back in a matter of months to weeks. So hopefully not over a 20-year period. That would be insane. So anyway, so why didn't I just call this profit? And I want to do that because it's important. We need to break this out. We need to figure out what this is. So let's just bring it back to the beginning here. So X so your revenue minus your cost per part minus your startup cost equals 0. So let's look at this. So I just don't call this profit because we need to understand what our revenue is and what our cost is. So our revenue is made up of, market research. So if you want to go make hats or shoes or whatever, pens, jets, you figure out what your customer is willing to pay. So what the customer is willing to pay. And your cost is two things. It's your setup cost. Oh, we'll go back. It's your labor and the material. So to make anything, you got to buy material and you got to pay somebody to do something, or you got to pay for a machine to operate. No matter if it's automated or not, there's still something you got to pay to make that thing. You can't get something from nothing. Okay, so in that material, this breaks down even further. So material turns into the part cost and the scrap. Okay, so this scrap you can often sell at a significantly reduced rate, like that you purchased the original material for, but you can still make your money back on it, and you should, because it makes economic sense. All right, and then your labor. Okay, so and that breaks it down into your setup costs and your process cost. So setup being like, okay, I have to do, I have to set up the machine. I have to install all the tools. I got to measure all the tools. I got to, do all these sorts of things. So I got to, turn the machine on. I have to, there's a lot of things to get things set up. You got to screw or bolt the fixture to the surface plate. And so anything that you can do to reduce your setup is really key there. because that just adds to your labor. And so your process, again, if you can do anything to speed up your process, that improves your labor, so reduces your labor. And so if you look at this relationship, if your revenue, if you can sell the part for more, your profit goes up. If you can make the part for less, your profit goes up. So, a company, a manufacturer will focus on both of these. They'll have people within the factory focusing on reducing costs, and they'll have sales people who are trying to increase, maybe they can't increase the overall part or the overall price. Often you can't in a competitive market. But what they can do is sell more. So you just sell more product and you have a bigger piece of the pie. So the pie, or and essentially, or make the pie bigger. Tell people you need a product. So that's it. So then your startup costs, they're something else. Startup costs turn into, cost of a machine. So if you already have machines, you don't need to buy a machine. It could also be the cost of prototype, so design. It could be the material involved, making the prototype. And finally, the tooling involved. So, machine costs, design costs, material costs, tooling costs. Those are typically what you see in your startup costs. And that's why it's broken out on its own. Because once you've paid this off, once you've met this, this zero relationship, you're just now focused on your profit. But this formula as a whole will find you your break-even point. So going back to the questions, I think you have valid questions, and I think that you may need to do a little bit of research to figure out what your costs are. But once you know where they go in this formula, everything makes a lot more sense. So let's do an example here. So we are going to make, let's see, let's say we're going to make something really useless. Let's make a fidget spinner. So somebody's life's work went into the design of this. There's a whole group of engineers and designers and technologists who figured out how to make this thing for cents. So you go to the gas station and you find that you can buy this thing for, let's say the market value is $2.50. All right. Okay, so market, that's my first assumption. So I assume, so this is an assumption. Okay, and then, let's say this thing, the setup costs are, $100 per hour. And per part takes about, the setup cost, let's say you make a batch of 50 of these in one go. So, you're going to spread that out of 50. So it's not $100. What am I trying to get at? It's $100 per hour, but how much of that hour was spent set up? So let's spread that out, and it was about 0.1 per part, hour per part. So we cancel the hours and we get $100, or we get that to be $10 per part. So already we know that we're not making money on this. So this number has to change, or this number needs to change. So we go back and we find out a better way to set it up. And we find out that we can export this and to another company, and they can, sell us this thing. Their setup costs are 0.001, hours per part spent on setup. So this is setup. And it only costs them, they're paying their people $10 an hour. So our hours cancel again, and we get, what would that be? About 10 cents per part. Yeah, I think so. 0.1 would be a buck. No, 1 cent. So 1 cent per part. Wow, they are just doing so good. Per part. So that's the setup. And then they figure out that the process, it costs about, I don't know, 50 cents per part. So that's what they figured out. All right, but we can break that down a little bit easier, right? So let's say, they pay the person $10 an hour. So that's their rate. So, sorry, this is process. So $10 per hour times, they can do about, 100 parts per hour. But you notice that it can't be times, because then you would get hours squared on the bottom, dollars per hour squared, so that doesn't really work. So you would get really strange units. So you know that this needs to be divided to get dollars per part. So they can get 100 parts per hour. So then your hours cancel, and you get $0.1. So that equals $0.1 per hour. Okay, so if we work this out, we get 250 minus per part, and we get 0.01 per part plus 0.1 per part. So now we figure out that our profit is actually quite good, and it's about $239 per part. That took away 11 from 250. Okay, and so let's look at our startup cost now. So we had to buy a machine that cost $10,000. And we needed to pay for the design, which, I don't know. This is machine. The design costs, $2,500, maybe even more. It's hard to know. I think I did this backwards. There we go. Design. Just get rid of that. And then we needed to buy, I don't know, we spent, $100 on prototyping material. And our tooling cost $1,000. Okay, so this whole thing added up together would be 13,600. Okay, so if we rewrite this into this, so how many parts do we need to sell to make back our 13,600? Okay, so it's go back to white here. So X is equal to, we'll go back to our nice formula here that we can use. So $13,000, 600 divided by 239 per part. So that would equal to 13,600 divided by 239. So we have to sell 5,690.37. So we actually have to sell one more, so 5,691. 5,691. Parts. Okay. So you can see how I've made these assumptions here. For your flywheel project, you should do a little bit of research. You should figure out, the cost of the material that goes into making a die, and the cost of material that goes into making a drill fixture. I would accept that if you said, let's say the labor costs, $1,000 because that's what they're going to charge us. If you want to assume that for the labor, that's fine. Now the CNC milling costs, you need to factor in your setup costs and your process costs, and your hourly rate and things like that. So use these formulas here. These kind of got sort of, maybe they weren't in the forefront as much as possible, so I can just break those out for you right now. So setup is equal to And the cost of the setup per part. So X value per part. And you need to multiply that by hours per part. So you're distributing the setup time over a batch of parts, and then, or if it's truly a one, setup per part, then it depends how many are in your batch, so you could assume your batch size as well. And then you need to multiply that by the hourly rate of your process. So X dollars per hour. And so your hours cancel and you're left with dollars per part. That's how you set up, that's your setup cost. And then your process cost is your hourly rate. So X dollars per hour, and divide that by how many parts you can make per hour. So X parts per hour. And so you can start to figure out how many parts you can make in an hour. So that's how that one works too. So anyway, I hope this is helpful. I do want you to do a little bit of research to figure out some of these costs here. So I'm not going to give it away. I just wanted to show you how this relationship of the break-even point works. And if you have any questions, please feel free to reach out to me. My email is sbroska, that's an E, at not Gmail, rrc.ca. So please feel free to reach out to me, and I'm happy to help. Thank you.